Okay, here we are with our Unit 1 summative review. Made it through Unit 1. Okay, so the first part of this packet is really just the same as the Unit 1 formative review, right? So there was some basic vocabulary that you needed to know. We talked about translations. We went over reflections, more reflections. What else? Reflections, rotations, of course. So if you're wanting to go through, those basics for transformations, your vocabulary, translations, reflections, or rotations. Actually, now I just realized we didn't go through rotations in that packet, so let's do that. Let's at least go through some of the rotations. But if you're looking for translations, reflections, or vocabulary, you need to check out the Ed puzzle for the formative. Okay, let's get started on rotations. So we have our rotation rules. I showed you a little neat way to remember your rules in a way that isn't as complicated as these tables give them to be. With rotations, we have some steps. First, label and plot the points of your pre-image and write the original points down. So that's going to be your first step. So say with 6, let's do 6. It says E is at -1, 2, 3, -3, and +1, 2, 3. Solid. And then we're going to leave a space for E prime. And then U is at 1 and 1, 2, 3, so 1, 3. And V is at -1, 2, 3, 4, -4, +1. Okay, and let's leave our spaces for U prime and V prime. Okay, so we wrote down our original points. Step 2, determine which rule you're using. Is it counterclockwise? Is it clockwise? 90, 180, 270? Okay, so this question says rotation. Okay, of course, rotation 90 degrees counterclockwise. Counterclockwise is our default, and this problem just says, go counterclockwise. Okay, so number 3, perform the rule to each of your original pre-image points. So if we're going to do the rule, we have to know what the rule is, right? So remember what you're going to do is 90, 180, 270, and box it. This is counterclockwise, and then beside it, flipped those numbers is your clockwise. So 270, 180, 90. Okay, how do we do the pattern? It goes Y, X, Y, X, Y, X, first, both, second, okay? And we already said for number 2, which rule are we using? We're using 90 degrees counterclockwise. So I look right here under counterclockwise, I go to 90 and I see I'm switching the numbers and I'm changing the sign on the original Y. So, okay, yeah, number 3, perform the rule to each of your original pre-image points. So we're going to be using this rule. So if I flip, this is my X, this is my Y. If I'm switching these numbers and I change the sign on the original Y, which is a +3, this +3 becomes a -3. So that means I'm switching a -3 and a -3. So I get -3, -3. Oh, that kind of went off the page. That's okay. For U, this is my X, this is my Y. The rule says I change the sign on the original Y. So that +3 is going to be a -3. So really I'm switching 1 and -3. So I get -3 and 1. And then finally V is originally, so -4 is the X, the +1 is the Y. I change the sign on the Y. it becomes a -1. So I'm switching -4 and -1. So I get -1, -4. Last step, plot your new image points and label your figure as the image. Okay, so these are the answers right there. E prime is at -3, -3. 1, 2, wait, 1, 2, 3, 1, 2, 3. E prime. U prime is at -3, -1. 1, 2, 3, -1. U prime. And V prime is at -1, -4. 1, 2, 3, 4. Like that. Last step, connect the dots. Oh. One day I'll draw a straight line. Okay, but the points are in the right spot. So it's the right answer, right? This is the image. This is our pre-image. And so this triangle got rotated 90 degrees, or sorry, the better way to think about it is it got rotated 90 degrees counterclockwise like that. So that you can like follow my finger for the point V. It went 90 degrees counterclockwise, and that's how you do that. So for each of these questions, it's all of the same steps. Number one, you label and plot your points of the pre-image. So it'll either give you a graph or it'll give you the original points, and you'll write them down. Number two, you'll determine which rule you're using. Hopefully you've already written your rules down, so you don't even have to think about that. Determine which rule you're using. So this one says 90 degrees clockwise. So I wouldn't be in this column. I would be in this column, the clockwise column, and I would go down here to 90, and I would switch the numbers, change the sign on the original X. So it all just depends on what the question tells you. You perform the rule, and then you plot the points. Not too bad. Okay, let's get into some semi-new stuff. So we've done this like a little bit, but not quite a lot. So there's this thing called composite transformations. That's when you do like one transformation, then you do another transformation, and you can even do another transformation. You can go on forever. Usually they're only two-step. So the steps for a composite transformation is step one, determine the pre-image and label the points and write the original points and graph the pre-image. So let's do that for number 8 right here. The vertices of ABC are 2, 4. Let's plot that. 2, wait, 1, 2, 1, 2, 3. Oh, it's like a little above. Is it really just a little above the graph? That's so odd. 1, 2, yep. 1, 2, 3. Oh, it's going to be right there. Or that's just our A. B is at, well, what's going on here? Why would they give you a graph that was too, hold on. Okay, figured it out. So there are some problems where they kind of force you to do it algebraically instead of graphically. So since these points aren't going to fit on the graph that it gave us, we're going to have to do it algebraically, which we've done before, so no big deal. So the original A is at 2, 4, and so we're looking for A prime. So if I take, so 2 is the X, 4 is the Y, and so I take that 2, and I say, okay, it's 2 minus 4. 2 minus 4 is -2. Y is 4, and I do 4 minus 3. 4 minus 3 is 1. So I can plot that. -2, +1, A prime. Our B prime, the original B is 7, 6. So I can do 7, 7 minus 4, just 3. And then 6, 6 is the Y, so 6 minus 3 is 3. B prime is at 3, 3. And then C prime is at 5, 2. So I do 5 minus 4 is 1, and 2 minus 3, which is -1. You can plot these 2 points. So I already did 3, 3, and then just C left. So 1 and -1, C prime. You can connect your dots together. However, we are not done, right? Because this is a composite transformation. This was the first transformation. Now we need to do the second. So we did step 2, perform the first transformation. Now we're doing step 3, perform the second transformation. So now we're going off of these points, right? We're absolutely not using the beginning points. We're using the middle points, if you will. And we're going to use these points and we're going to reflect across the x-axis. You can do this one of 2 ways, right? You can use your x-axis rule, which is you change the sign on your y-coordinate. So if I did that, A double prime would be -2, -1. And look back at your reflection rules for those rules. B double prime would be 3, -3, change the sign on the y. And C double prime is 1, and this is a -1, so I change the sign and it becomes a +1. So 1, 1, and this is our final answer. So yeah, A is at -2, -1, A double prime. And remember, you can actually also do this graphically if you have a graph. So C is, and our line of reflection is the x-axis. So C is 1 down from the x-axis. So you can just go 1 up from the x-axis, and that's your C double prime. B is 1, 2, 3 above the x-axis. So I can go down 1, 2, 3 below the x-axis. And so you can either do it algebraically like we did right here, or you can do it graphically, whatever floats your boat. Oh, wow. Okay, sorry about my lines. It's awful. Okay, but this is our final image right here with the double primes, this triangle. Okay, the main thing with this is just to make sure you're doing it in order and you're writing down your coordinates. Writing down the coordinates helps so much with composite transformations because it gets to be a lot of numbers in your head or on the page. Okay, last class we talked about reflectional symmetry and rotational symmetry. So with reflectional symmetry, we have our lines of symmetry. Rotational symmetry, you want it to map back onto itself. If it's a regular polygon, remember that you can do 360 divided by the number of sides. Yeah, but we're gonna just get right back into it as a review. So how many lines of symmetry does this rectangle have? It's on a graph, but that's not going to deter us. So a rectangle has 2 lines of reflection. We talked about that the other day. That would be a line of reflection going straight down the rectangle. And actually, the x-axis right here would be a line of reflection because that goes straight down the middle as well. So those are our 2 lines of symmetry. And it says, given the lines of reflection, give the lines of reflection that would put the figure onto itself. So these are the lines that would put the figure onto itself because they're the lines of symmetry. Now we just need to give the equations of the lines. For the x-axis goes through the y-axis. So I write y equals, and where does the x-axis go through the y-axis? It goes through at the point 0. So that's one of the equations. And we need this equation as well. This is at point 1, 2, 3, 1, 2, 3, 4. This is at x equals 4. The line goes through the x-axis. So I write x equals, and it goes through at 4. So when it's a graphing problem, first you need to figure out what is the line of symmetry. You can draw that or just, visualize it in your head. And then after that, they'll usually ask you, what is the equation of the line of reflection that would map it back onto itself. And so like if I flipped around that line, it would reflect onto itself. Okay, so we kind of actually already did a rectangle. A rectangle has two lines of symmetry. And if I rotate it 180 and 360, so 180 and then all the way back to 360 would get it back onto itself. This is a parallelogram. It has no lines of reflection, but 180 and 360 work for it for rotations. Something to note, so this is a parallelogram, but you can also have there's another shape that kind of looks like a parallelogram. It's called a rhombus, also known as a diamond. So a rhombus, and sometimes you'll see it like this, where like the edge is flat on the paper. A rhombus, so rhombus has two lines of symmetry, and they're the diagonals. So that's something to remember, most definitely. Remember that a rhombus has two lines of symmetry. And this right here, this is our pentagon that we've worked with before, and it's a regular polygon. With a regular polygon, you can use, and regular polygon, remember, it has the side lengths are the same, and the internal angles are the same. So examples of regular polygons would be, like a triangle, a square, a pentagon, a hexagon, a octagon, all the gons. But also remember triangle and square. Those are regular polygons. So we can do 360 divided by 5, the number of sides, to get, I just did this the other day. Hold on 1 second. To get 72. And then you do all the multiples of 72. So 72 times 2, 144. 72 times 3, 216. 72 times 4, 288. And 72 times 5, 360. So these are all of the degrees that would map this figure back onto itself. And remember that if it's a regular polygon, then the lines of reflection, number of lines of, I should say symmetry actually, of symmetry equals 5. It equals 5 because this is a regular polygon, and this regular polygon has 5 sides. So equilateral triangle, square, pentagon, hexagon, octagon, those are your regular polygons. Look back in the class video for this problem, or wait, sorry, this one is important. So Kiwana claims that all rotations I shouldn't say of 30 degrees will map an equilateral triangle onto itself. Is she correct? Why or why not? Well, let's think about an equilateral triangle like this. An equilateral triangle, and we kind of just talked about it, an equilateral triangle is a regular polygon. So we can use our rule 360 divided by the number of sides, which is 3. And so 360 divided by 3 is 120. So we can actually maybe even stop here because it says Kiwana claims that all rotations of 30 degrees will map an equilateral triangle onto itself. Is she correct? Why or why not? Well, 120 is bigger than 30. So a 30-degree rotation, so you can even imagine it, like if I move this corner like 30 degrees, that's not going to match up with this corner. It's not going to match up with itself. The earliest matchup, if you will, the earliest time that this figure will match up with itself is at 120 degrees. So no, not all rotations of 30 degrees will map an equilateral triangle onto itself. Some of them will, but not all of them. So like if you rotated 30 degrees 4 times, you would end up at 120, but 30 degrees by itself will not map it onto itself. So no, not all 30-degree rotations map. Yeah. And the reason is like it's not a large enough degree of rotation. Not large enough. You would need 120. The ones that would work would be 120. Oh, wait. Times 2. 120, 240, and 360. So 120 times 1, 120 times 2, 120 times 3. These are the degrees that works for an equilateral triangle. Okay. And last one, mapping onto. So mapping onto is the same. So mapping and onto mean the same thing. You want the shape to land back on itself and you want it to match up perfectly. So with ones like this, it might ask you, specify a sequence of transformations that will map one shape to another shape. So in this case, it's ABCD to PQRS. So you just have to determine what transformations would get you there. You could maybe like even write down like what you think the two transformations are before you even get started. When I'm looking at this one, I notice that this rectangle is not right side up with this rectangle. So it looks like a rotation needs to happen, right? And it's gonna need to be a rotation of 90 not counterclockwise, because that would be over here, clockwise, because we're going this way. So number 1, rotate 90 clockwise. And you can verify that with your rules. So if I looked at the point C, and C is originally at 1, 3, the rule for 90 degrees clockwise is you switch the numbers and you change the sign on the original X. So C prime would be 3 and -1. Is that correct? Wait, 1, 3, 1, 3. Let me hold on. This is why it's always a good practice to write down your rules. Y, X, Y, X, Y, X. Yeah, that's, wait, hold on. Three. Oh, yeah. I feel like 1, 1, and 1, 2, 3. Okay, yeah, sorry. I don't know why I'm second guessing myself like that. That's correct. Sorry. Anyway, so points verified. And this is 1, 2, 3, 4, 4 tall. So 1, 2, 3, 4. So this is what the rotation would look like that if you rotated 90 clockwise. And then last step, it looks like you would need to translate down. And then how many points would it need to go down? This corner is right here. And to get it to match up with this corner, I would need to go down 1, 2, 3. Translate down 3 units. Yeah, and that's mapping onto, we got the pre-image to land directly on top of the image through 2 transformations. Okay, and that's unit 1, guys. It's a wrap. Hope this was useful. Reach out to me if you're having any questions with anything particular with IXL or with this summative review, and I'll see you soon.